Right, good day again, guys. Good day. Mr. Lembete here from Garage Maths SA. We are here to look at a problem that we actually did during our cross night under trigonometry, which was really interesting. Very, very interesting stuff that we looked at here. So it is this problem here. I'll just snip it and place it there so that you can be busy with it. So this was the problem. Very interesting, a brilliant problem. I liked it very much. Maybe whilst I do this, or in fact no, not whilst I do this, what you can do is that maybe before I even give you the solution to it, you can pause the video, attempt it on your own first, and see how far you go. Né? Okay, so it says here, if sine 18 degrees is t, use a diagram and determine the following in terms of t. Now here, and people are going to say, hey, I loves diagram questions. Yes, I do. They are very nice. But also because this one, I like the second part of it. It says by using identities, verify your answer. That's the part I'm actually gunning for. But before that, we have to answer the first one to be able to do the second part as well. So we know for a fact that since they said it is sine 18, sine 18 is equal to t, we know that we are definitely sketching in the first quadrant, because sine 18 degrees is found between 0 degrees and 90 degrees. So that's why we sketch first quadrant. Then we write our 18 here. And of course, since this is 18, this will be 72, because 72 and 18 should give us 90, and the sum of angles of a triangle, interior angles of a triangle, should give us 180. So this is our diagram so far. Now it said sine t, and remember, and according to our current knowledge of trigonometry, there's this mnemonic that we use, which is called SOHCAHTOA. So this means sine is opposite, so opposite is t, hypotenuse is 1. And if that's the case, according to Pythagoras, this will be the root of 1 minus t squared. And in case you're not sure how that came about, well, we know that r squared is in fact equal to x squared plus y squared. This is Pythagoras, not Mr. Lembete, Pythagoras. So in this case, r is 1 squared is 1, x is the unknown, and y squared is t squared. So that's x squared. So now we want to solve for x. So this says x squared is the same as 1 squared, which is 1 minus t squared. And therefore x, oopsie daisy, let's just go back, and therefore x will be plus minus the root of 1 minus t squared. This would be the outcome. But since here we are in the first quadrant, the x values here are positive, so for that reason we will do away with this plus minus and just leave it as a positive root of 1 minus t squared. So easy stuff, not difficult. Now let's solve. Since we've now got this here, we can now solve. So the first part, they say here cos 18 degrees times tan squared 18 degrees divided by sine 18 degrees. So this is nice. Cos is ka, which is adjacent over hypotenuse. So this means we are going to have adjacent, which is the root of 1 minus t squared, over the hypotenuse, which is 1, times tan is going to be toa, which is opposite over adjacent. So this will be t over the root of 1 minus t squared. And since tan squared, this is going to be squared. Then sine, of course, sine 18 is just t. So this is what we have. This is what we have, good people. And I like it because now we can further simplify. This is the root of 1 minus t all squared divided by 1 times, now t squared is t squared. The root of 1 minus t squared is just going to be, or all squared is just going to be 1 minus t squared. And of course, this, good people, I'll just put it here in brackets, is the same, or is divided, sorry, by 1 over t. Now, since these are fractions, this means I'm going to have t squared times the root of 1 minus t squared times 1, which is just t squared times the root of 1 minus t squared, all over 1 times 1 minus t squared times t. So this is going to be t times 1 minus t squared. Hopefully you are still following so far. And of course the mentality here, or the understanding we are currently using, is this. I'll just put it here on the side in red, that if we are multiplying fractions, we simply multiply numerators alone and we multiply denominators alone. That's so hopefully this will now be clear. Now, having said that, let's carry on and further simplify this. We realize this is t squared here, this is t, so t squared and t can now divide, and when that happens we are going to be left with t times the root of 1 minus t squared, and in the bottom we will be left with just the root of 1 minus, oh sorry, not the root, there's no root here. We'll just be left with 1 minus t squared, which was under a root before. There before we, oh no, sorry, it was never under a root, it's down on top. Sorry for that. So this would be our solution there. That would be our solution. Now let's go and look at the second part. It says here now, by using identities, that's the hint, verify your answer. So it means that when we are using identities, we must get an answer which is t times the root of 1 minus t squared all over 1 minus t squared. So let's do that. So let's do that. Here's number 2 here. We are now going to use identities. Oops, sorry, it's the cos of 18 degrees times tan squared of 18 degrees divided by sine 18 degrees. So let's use identities. Well, firstly we can just see here there is tan, so that's our first identity we are gunning for. So this means now we are going to have sine squared 18, because remember tan theta is the same as sine theta over cos theta, ne? Over cos squared 18 degrees this is over 1, ne? And this is all going to be divided or times 1 over sine 18. Hopefully so far so good. What's going to happen now is very marvelous, because you see 1 cos 18 will now divide with 1 cos 18 here, and 1 sine 18 from here will divide with this 1 sine 18 here. So this means we'll now be left with, what's left? Cos 18 gone, so this is just 1. We are going to be left with, this is beautiful, 1 of the sine 18s here, so sine 18 divided by 1 of the cos 18s here, because there were 2, which is just cos 18. Interesting enough, sine 18 over cos 18 will just be tan 18 degrees. Okay, now let's go to our diagram. Tan is opposite over adjacent, so tan is t all over the root of 1 minus t squared. So let's write that down. Tan is t divided by the root of 1 minus t squared. Okay, let us compare our solutions. Are they the same? Interesting. Are our solutions the same? Well, they, from the onset, okay, let me just fix this. From the onset they don't look the same, no? They don't. But because maths is a beautiful thing, for you to be able to see this, let me demonstrate here on the side. I'll just use my green pen here. What if I've got k divided by the root of b? If I was to rationalize this, I would have to multiply by the root of b over the root of b, which is just a strategic one, and this would result in a situation where I've got k times the root of b divided by just b. Isn't that so? Okay, so this means if I've got t divided by the root of 1 minus t squared, I can also rationalize it by simply multiplying by the root of 1 minus t squared divided by the root of 1 minus t squared. And will you look at that, when multiplying fractions we multiply numerators alone, so this is t times the root of 1 minus t squared, and when we are multiplying fractions we multiply denominators alone, so this just becomes 1 minus t squared. And if that's confusing, you should recall in grade 11 we did do this under algebra, that the root of a times the root of b is the same as the root of a times b, which means a special case of that will be that the root of a times the root of a is in fact the root of a times a, which is a squared, which just becomes a. And because of this we can now apply it here as well. And if you look at that, this solution is the same as this solution, and thus we have verified this. Yes, so this was a very fun problem to do, a problem that we did with my grade 12s on Friday night, or was it early Saturday? I'm not sure. It was at night. But yeah, that's the problem we did. Very fun, very fun. We had a lot of fun doing it. Guys, we are available again online with our tuition program. Just click on the on our bio there, click on the link, fill the Google form, and we will be in touch with you shortly. In terms of pricing, it is just $200 per session, and each session is 2 hours. We can do more than 2 hours depending on the topic we are doing, and of course that will be at no extra charge or cost to you. So yeah, that's our online classes there. Otherwise, this is Mr. Lembete from Garage Maths SA. Until next time, cheers.